This is CCM8, Unit 4, Lesson 1, Positive Scientific Notation. Some definitions first. Standard form is the normal way to write a number. So we could have 211, 1,269,000. That's the normal way to write a number. Scientific notation is a way to write a really big or really small number. For example, 1.7 times 10 to the 9th power. So that represents 1,700,000,000 when you write it all out. So it's just a way to shorten really large or really small numbers. So Vic number 1. I normally use a template to help me write numbers in scientific notation. Here's the template. Blank times 10 raised to the blank power. So you've got a number. This number here in this first blank must be a number in between 1 and 10. It can be 1, it cannot be 10. So that's what's written here. If you think about it, can be a one-digit number, but it cannot go all the way to the tens place. It can be a decimal, but the decimal has to be in between 1 and 10. It can be 1.25, it could be 9.99, it just cannot be in the tens place. It cannot be 10.62. That's too much. So it's going to be a number in between 1 and 10. It can be 1, it cannot be 10. And then it's times 10 raised to whatever power. Could be raised to the first power, 10th power, negative 20th power. But that's how we write scientific notation. Sometimes in your calculator, when you type in a really large number or you're multiplying some numbers together, your calculator will actually give you an answer in scientific notation. Except for your calculator shows 1.2 E12. And what that E stands for is this part right here, the times 10. So if you ever notice that in your calculator, that's what your calculator is doing. It's shortening a really large or really small number. Vic number 2, the exponent is telling you to move that many places in value, not necessarily how many zeros to add. I think that's a big misconception. You're moving in place value. Just because it says this exponent is 10 doesn't mean you just add 10 zeros to the end of your number. So be very careful about that. And then if a number has an exponent, if a number has no exponent, it is understood that it has an exponent of 1. So, sorry about that. If you see that a number has an like 10 raised to no power, then that's automatically 10 to the first power. All right, moving on. Here are some examples of numbers in scientific notation. 4.2 times 10 to the 6th power. 1.01 times 10 to the 10th power, or 9.99 times 10 to the 3rd power. Those are all examples of numbers in scientific notation. They fit all the criteria. Here are some numbers that are not in scientific notation. 16.1 times 10 to the 4th power. So that's a number bigger than 10, which I was telling you earlier you cannot have. Again, 113 times 10 to the 7th power, it doesn't fit our criteria. And then 0.02 times 10 to the 5th power, that is a number smaller than 1, so this number does not fit into scientific notation either. I'll show you in a future video how to change numbers that are not in scientific notation to a number that is in scientific notation without expanding it and then shortening it back. All right, let's do some basic problems. Let's change these numbers into scientific notation. They're in standard form. So to do that, you'll need to look at your number. I've got a whole number. So in my whole number, I need to find out where my decimal would be. In a whole number, your decimal is going to be here at the end. So I'm going to start with my decimal, and remember, I'm going to write my answer in scientific notation with the template, blank times 10 raised to the blank power. So to get my first number here, I have to move the decimal so that I'm creating a new number in between 1 and 10. And then the exponent is how many times I move the decimal to get there. So I'm going to move and count as I go. 1, 2, 3. That's 3 places. And my new number is 5.69. Because that's where my decimal is going to be after I move it 3 places to the left. If I move the decimal to the left, I have a positive exponent. All right, let's try the next one. Blank times 10 to the blank power. So I need to find my decimal and a whole number. Your decimal is going to be here at the end, and you just count. 1, 2, 3, 4, 5. That's where I'm going to stop. I'm going to stop at the 2.67, and I went 5 places. Hope that makes sense. One last one. Blank times 10 to the blank power. See if you can do this one here on your own paper. All right, did you get what I got? 4.6205 times 10 to the 7th power. All right, let's change these numbers that are in scientific notation. Let's change them into standard form. To do that, I'm just going to start with my number here, and I'm actually going to do the opposite of what I was doing before. I was moving to the left before, and now I'm going to take the decimal, move it to the right, however many places it's telling me to move. So I'm going to move it 4 places to the right, and my end result is my final answer. 1, 2, 3, 4. And that's where my decimal is going to be at the end of my number. Now what do I do with all these blank spaces? I fill them in with zeros. And I rewrite my new number. And you can put a comma, 50,700. Here goes my next number. It looks like I'm going to be moving the decimal a lot. So here I go. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. That's a lot of zeros that I'm going to fill in the place values that I've moved. Remember, you're only moving place values. You don't necessarily just add 12 zeros. In this case, I've only got, it looks like 11 zeros. Let's rewrite our number. 3, 2, and then 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0. And then you can add commas to see how big this number is. So it looks like it's 3,200,000,000,000. That's a very large number. And you can see that scientific notation helps us shorten those really big numbers. Lastly, why don't you pause the video here and you try this one. Did you get 1,550,000? If so, you're good to go.